So this is a relatively new course offered by Asian Open Run, an introduction to artificial intelligence and machine learning. Now you may be wondering, aren't we a bit veering away already to the original offerings of Asian Open Run, which is, as mentioned, also a primary focus on the telecommunications field. No? But if you are to think about it, especially in the ongoing trends nowadays, almost anybody and everybody is already onboarding into artificial intelligence AI. And that is actually one of the primary reasons why we've also incorporated this as part of the offerings that we have as part of our foundational courses at that. No? Now, this course was actually created by one of our co-creators also, Mel Alipio, and I'll be the one to provide you at least the high-level details of what this course would be about. We have a separate course also that I have personally created that is called Natural Language Processing, although it is already a subset of artificial intelligence AI. This course primarily focuses really more on the foundations. Okay. Now you may be wondering, where does now AI come in into our open radio access network and at a bigger scope, our telecommunications field. Think of it this way. Our telecommunications network nowadays is already driven or is data driven. And in fact, most of the capacity management, operations management, planning, the entire life cycle of a network service from the moment that a service or a device has been provisioned up until its decommission time, most of these activities are done manually. In other words, we have already we rely on our planners and our engineers in order to configure and do the necessary changes from provisioning time up until decommissioning all of the functions and processes found in the telco plane. Now, I'm not alluding that AI would eventually replace the functions and roles of these planners and engineers that we have. In fact, AI in its current state of technology is still dependent and in fact complementary to what us humans can still be doing. And think of it as not as a replacement, but as another tool that you can put into your personal knowledge arsenal. So having said that, majority of the data in our telecommunications can actually be considered also as inputs and triggers to models, which would be the primary focus of this course. The creation of models and training the models such that data analytics can now be considered as one of the primary drivers in order to not only optimize the existing network, but also to foresee possible changes within the network from the wireless up to the core network. So that might sound a bit of a stretch already as a concept and one of the huge promises of AI, especially in the telco perspective. The course or this course itself primarily focuses really more on setting you up on AI and machine learning as basic concepts. Okay? So that's why I'll go here now to the course overview. The intention on why we are offering ML, machine learning and AI, is for you guys to first understand or at least have a brief concept on what AI and ML is, as well as have a brief overview on what the workflow process is, specifically for machine learning. Now, the primary focus of this course is really more on machine learning, which is, if we're going to look at it from AI perspective, is a subset of AI. Later on, I'll be also giving to you a quick overview of what machine learning is and how it plays AI. But here's the high level content of the course. It would focus more on different types of machine learning techniques, no? Specifically, supervised and unsupervised machine learning. Apart from that, you'll also be learning here the implementation and understanding of data pre-processing techniques, because definitely when we deal with machine learning, we'll be dealing with also data analytics and data science. Okay? The creation of models can only go so far given that the data it feeds into or what learns from is correct and consistent. Okay, so that's the focus of one module. Another module now, or the rest of the modules, would now be focused more on the two subsets of machine learning, which is supervised and unsupervised learning. No, okay. Now, this is a pretty much hands-on course. No? I say this is because, again, we'll be veering away first on the concepts of telecommunications, and we would be focusing here more on the concept of computer science and data science or data analytics. Having said that, no, some of the course is intended to be run through using Python as its main programming language. But if you also have other languages that you are comfortable with using, such as the likes of Rust or even C or even R programming language, these can also be applied using those. Okay. Now, Module 1 would focus really on introduction to what is artificial intelligence and machine learning. This is what I'll be talking about later on in the when I go through briefly what is AI and ML. Next one is the different types of machine learning techniques. So we have what's called supervised and unsupervised learning model, as well as a combination of the two, which is called reinforcement. Okay. The next module is now pre-processing data. This is where now the concepts of ETL would be coming in: extract, transform, and load, wherein you are given a set of data sets, and from there, at least have or process it in a way that would be useful to your models once you start creating them. No? Now, the rest of the modules would now primarily focus on the different use cases of machine learning. So module 4 is more on prediction, regression. So there are different types of regression techniques. Some of them is what's called linear regression. There's also logistic regression. Its intention, regression, no, as a technique, no, is for you to predict a certain value based on existing ones. Okay? And that prediction can come in the form of a numerical value, in the form of a linear regression, or it can come in the form of either a discrete value, which can come in the form of logistic regression. So when we talk about logistic regression, normally it is either a 1 or a 0, a high or a low, no, based on previous inputs. Okay? So other techniques would involve classification and clustering. Classification based on the k-means method. We also have the support vector machine and k-means clustering. Okay, so these are, if regression is more on value prediction, clustering and classification really more on or falls on, say you are given a specific data set, you now train a certain model in order to give it a certain classification. Okay, so as these terms imply, no? Meaning that I have 100 data sets, and these 100 data sets are, from example, different, let's say, the CPU utilization of your eNode Bs. Okay, from there you can now train a certain model and gain insight on whether these eNodes can be classified based on their CPU threshold, and from there understand, do these specific node Bs have a common trait? Why is it that all of them are clustered together? say in 70% utilization versus these that are in 80% utilization. So from there, we can already gain insight just by having an understanding on how they are classified. Next one, we also have hyperparameter tuning and evaluation metrics. This is also module 6 is more on optimization already of your models. Okay? It's not enough that you create um, models or machine learning models from your data sets. You also have to understand that whenever you feed the model a certain data, you need to get whether the output that it would produce is accurate and precise. No? And you also, from here, you would also understand what are data outliers, meaning that suppose you have a given data set and this data set does not fit in any or all of the parameters from other existing ones. So these can be classified as outliers. And how can you train your model to be more robust when dealing with said outliers? So that is the focus of module 7. And finally, module 6. No? And finally, module 7, this is now, we would now be incorporating some concepts of Open RAN into machine learning. Like what I have said, no, especially in monitoring the operations of the different components in our Open RAN. No? This is the operation itself handles a lot of data. Okay? And these data can actually be used to further optimize the performance and give the network itself a bit of fine tuning so that it can now intelligently predict, say, this certain site has high utilization. You can feed it with a given model, and this model can now um, either do its own optimization or feed it to the network or to the engineers and gain better insight on what can be done on that specific um, station. No? So there are a lot of use cases wherein we can already apply ML into telecommunications perspective, and that is would be the focus of module 7. Now, just a quick gist on what is artificial intelligence. No? So AI, this is a simulation of intelligent human behavior. Now, AI itself is a highly complex science. Okay? This doesn't just involve machine learning. This doesn't just involve creation of what's called neural networks, although they are a part of it. No, it also covers some aspects that are overlapping with robotics and mechatronics. Okay. So if machine learning and deep learning is really more on mimicking the human intellect or the human mind, no? There is also an aspect of artificial intelligence where we want to mimic the motions and mechanics of the human body. So this is where robotics would also come in. But the focus of this of our course is really more on simulation of the human intellect and human behavior. Okay, I won't be going through some of these slides. I'll be skipping some of them. Now, what are some AI-driven applications here? I think some of these you're already familiar with. No, we have robotics in autonomy, industrial and automation, predictive maintenance. This is actually one of the niches where telecommunications would be coming in, wherein you are given your network data, are a model can then be trained into understanding or gaining insight on this network, okay, and at least give a recommendation on what is the best course of action to be taken to optimize the performance of that network. No? Apart from that, there's also use cases specific for healthcare, for electricity, automated driving, and even entertainment. Okay, so your Chat GPT, if you are familiar with that, or Google Bard, those are examples also of your AI use cases, specifically general purpose. And it also deals not just in machine learning, but a little subset also of natural language processing, which is also a subset of AI intended to gain understanding or to have computers and computer systems mimic human speech, or human language. Okay? Now, AI is a broader term and machine learning is a subset of it. There is also a subset of machine learning called deep learning. Okay? So how do we differentiate the three? So the purpose of machine learning is really you feed your models with data, and from there, train a program that would produce unintended results. Normally, when you have programming, it's the other way around. Wherein before you write a program, no, you need to first create an algorithm. It would tell you the step-by-step process on how that program would run through, and it would produce as in, the intended result. In machine learning, it's the other way around. You feed it with data, and that data would then be used by the model to train and produce a desired result. Okay? Now, they can generate the desired output, but they aren't composed of a sequence of operations like a typical program or algorithm would possess. Okay? Now, machine learning is a subset of, deep learning is a subset of machine learning. How is that? In example, linear regression or logistic regression, no, normally you can also use algorithms or rather mathematical equations in order to produce a specific result. No? Deep learning takes it one step further. Okay? In deep learning, you now create what's called neural networks. Okay, so it is an entity or an object that is almost akin to a neuron. So it is represented similar to that of a neuron or the cell of the brain cell. No? And from there, form interconnections within these neurons, which would then yield an intended result. Okay, so it's still machine learning, but it is approached differently. Okay, instead of you creating algorithms, you create what's called neurons, which are objects. In fact, and they are still being programmed at least. Okay, one key advantage of deep learning is that it removes the need for manual data processing steps, similar to what you would have in your high-level machine learning, no, and extensive domain knowledge required for other techniques. Okay, so I think I will just stop here due to the lack of time, no, but there are still a lot of concepts still to be learned in AI. Again, this is a new course for us to be offered, and not only will you be learning machine learning at that as a concept itself, but you also get to practice your programming skills if you're into that. No? So because again, this is a course that is mainly a hands-on driven course, no? Because you'll be creating a lot of models, no, specifically in Python. Okay.